Hello, good morning, dear students. Welcome to Interactive Virtual Class Nagaland once again. I hope all of you are doing well. Dear students, so in today's class, we will quickly recall and revise on the chapter Atoms and Molecules. So before we look into today's class, let us quickly revise, recall on the terms atoms. So we have seen that all matters around us are made up of atoms, and these atoms, they combine together to form molecules, right? If the atom of the same type combine together, they form elements, but if the atoms of different types combine together, they form compound. So atoms combine to form molecules. So today we will learn about chemical formula, how to write the chemical formula for each molecule. But before we look into that, let us see this one. Here we see an octopus, right? We see that octopus has 8 arms. Here one boy is holding the 2 arms of octopus, right? Now how many more person do we need to hold all the arms of this octopus? The octopus has 8 arms: 1, 2, 3, 4, 5, 6, and 7 and 8. 2 arms is held by 1 person. So how many more person do we need to hold all the arms of this octopus? So we'll need 1, 2, 3, right? So we'll need 3 more persons to hold all the arms of the octopus. So by combining their power together, they are holding the octopus. Yes. So let us see. Similarly in element, the combining power of an element is known as its valency. One element, for taking the example of carbon, the carbon can combine with 4 other atoms. So it means the combining power of carbon is 4, the valency of carbon is 4. So the combining power of an element is known as its valency. All right. Alright students, so let us see sodium chloride. Sodium chloride is a compound. It is formed by combining sodium and chlorine atom. It is given by the formula NaCl. Hydrochloric acid is formed by combining hydrogen and chlorine. It is given by the formula HCl, right? So the chemical formula of a compound is a symbolic representation of its composition. From this chemical formula, we can know that the components of hydrochloric acid is hydrogen and chlorine. And similarly for sodium chloride, from this chemical formula, we can know that the composition or the components of sodium chloride is sodium and chlorine. So what is chemical formula? Let us see. Alright, so chemical formula is the representation of the components of the compound. So how do we write this chemical formula? Components required to write a chemical formula. Let us see. So the first is the symbol of elements. We will need the symbols of the elements. We will need the valency of elements. So those are the required components to write the chemical formula of a compound. If you can recall this formula to represent molecules. Oxygen molecule is made of 2 oxygen atoms, but we do not represent as 2O. Because when we write as 2O, this indicates 2 separate atoms of oxygen. Not the molecule, not the oxygen molecule, but when we write 2O, it means that there are 2 atoms of oxygen. So to represent the molecules, we will write in this way. First, write the symbol of the element, that is O for oxygen. So symbol of oxygen atom is O. Then subscript. At the subscript, we will write the number of atoms. So oxygen molecule is made up of 2 atoms. So we will write in this way, not this one. This is the correct way to write the formula for the molecules. So subscripted number indicate number of atoms of oxygen combined to form its molecule. Alright students, let us answer the first question for today. Please get your rough devices ready, students. The question is, the valency of nitrogen in ammonia is, I'm giving you 30 seconds for this question. Your time starts now. The valency of nitrogen in ammonia is option A 2, option B is 0, option C is 3, and option D is 4. Yes, students, which of the following option is the correct answer? Yes, students. Now, if you can recall the formula of ammonia, we have ammonia is written as NH3. So the valency of nitrogen in ammonia is, now this N is combined to 3 atoms of hydrogen. So N is combined to 3 atoms of hydrogen, meaning the valency of nitrogen in ammonia is 3. Okay, so the correct answer here is option C, that is 3. Alright. Alright, students, let us proceed. Let us see next. Okay. Similarly, chemical formula of compounds. We have seen how to write the chemical formula of molecules. Now, in compounds, okay, chemical formula of compounds. How do we write chemical formula of compounds? Let us see. Molecule of water, okay, is represented as H2O. Yes. Not. Okay, if the molecule contains one atom, subscript need not be written in the formula. So in molecule of water, there is only one atoms of hydrogen, so we do not need to write here 1. Okay. If the number of atoms is more than 1, then we have to mention, but if the number of atom is just 1, then we don't have to write H2O 1. Okay, just leave as H2O, because we will know that there is one atom of hydrogen from this formula itself. Okay. Carbon dioxide. Okay, carbon dioxide has C. Okay, the symbol of carbon is C. Dioxide means there are 2 oxygen atoms, so we write it as CO2. Okay, carbon monoxide, the symbol of carbon is C. Monoxide meaning there is 1 oxygen atom, so CO. Okay, so here we see that since here they contain 2 atoms of oxygen, we need to mention 2 as subscript in the subscript, but here they contain only 1 atoms of oxygen, so we do not have to mention CO1, just CO will do. Alright, so chemical formula of molecules increase cross method by using valency. Let us see example. Okay, sodium carbonate. Taking the example of sodium carbonate, let us see how to write the chemical formula of molecules in crisscross method. So the first step is write the symbols of each atom side by side, usually the cation first and anion next. Okay, so for sodium carbonate we have the symbol of sodium is Na and the symbol of carbonate is CO3. Okay, write the valency of each atom on the top of each symbol. So the valency of sodium is 1 and the valency of carbonate is CO3 2. Okay, the valency of carbonate is 2. So write the valency of each atom at the top of its symbol. The third step is divide the valency numbers by the highest common factor, if any, to get a simple ratio. So here we see the valency of sodium is 1 and the valency of carbonate is 2. So we do not, the highest common factor here is 1. So even if we divide by 1, we are going to get the same number. So here we do not have to divide. Now, the fourth step is interchange the valency and write the numbers to the lower right of the constituents as their subscripts. So interchange. This one will go here. These two will go here. Okay, so let us see. So we will see that the formula of sodium carbonate is Na2CO3 1. But we have seen that if it is 1, we do not have to mention that. Yes. So if any constituents receive the number 1, ignore it while writing the formula. If a constituent has more than 1 atom, enclose it within brackets. If it carries 2 or more ions, then mention it as subscripts. So here when we interchange the valency, it becomes 1, right? So we don't have to mention. But suppose this is 2, then we have to mention and put this within the bracket. Okay, so this is how we write the chemical formula of molecules in crisscross method. Okay, so let us see. Okay, let us learn how to write the chemical formula for some compound. For formula of hydrogen chloride. So symbol, hydrogen symbol is H. Okay, chloride symbol is Cl. Alright. The valency of hydrogen is 1. Yes. And the valency of chlorine is 1. So if we interchange, okay, their valency and write it as subscript, we will get H1Cl1, right? But since it is 1, we do not have to mention, so the chemical formula of hydrogen chloride can be written as HCl. Okay? Let us take another example. Formula of hydrogen sulfide. The symbol of hydrogen is H. The symbol of sulfide or sulfur is S. The valency of hydrogen is 1 and the valency of sulfur is 2. Now if we interchange their valency and write it as subscript, then we will get the formula for hydrogen sulfide is H2 and S1. It is 1, so we do not have to mention, so H2S. So this H2S is the chemical formula of hydrogen sulfide. Okay. Another example we have here is formula of carbon tetrachloride. So let us see. The symbol of carbon is C. Chloride is Cl. The valency of carbon is 4. Okay. And the valency of chlorine is 1. Now if we interchange their valency, we will get the chemical formula as CCl4. Yes, we interchange their valency, so we will get the formula CCl4. So this is the chemical formula of carbon tetrachloride. So the valencies or charges on the ions must balance. Okay. Now, names and symbols of some ions. So you have to write the chemical formula of the compounds. You have to know the symbol. Okay. You have to know the name of the element. You have to know the symbol. Okay. You have to know the valency. Okay. And you have to know the charges it carries. Okay. So by knowing that, you will be able to write the chemical formula of the compound. So some elements show more than one valency. You will see that some elements show more than one valency. For example, iron, right? Iron shows more than one valency. It shows valency 2, it shows valency 3 as well. Okay. So remember the valency of each of the ion, okay, and their symbol as well. So formula of some compounds, let us see. Okay. The formula of sodium carbonate is Na2CO3. Formula of sodium bicarbonate is NaHCO3. Formula of sodium hydroxide is NaOH. Formula of copper sulfate is CuSO4. Silver nitrate is AgNO3. Hydrochloric acid is HCl. Sulfuric acid is H2SO4. Nitric acid is HNO3. Ammonium chloride is NH4Cl. Potassium dichromate is K2Cr2O7. Potassium permanganate is KmNO4. So these are some of the formula given to us. Okay, you can write the chemical formula of all these compounds by making use of the method that we have learned by following step by step. Okay. Alright students, we have another question. Please get your rough devices ready. The question is the molecular formula of potassium nitrate is. I'm giving you 15 seconds for this question. Students, your time starts now. Yes, students. The molecular formula of potassium nitrate is. Alright, students. Yes, very good. The correct answer is option A, that is KNO3. Okay, the chemical formula of potassium is K. The chemical formula of nitrate is NO3. Okay, their valency are 1 1. Okay, so KNO3 is the chemical formula or the molecular formula of potassium nitrate. Alright students, let us see here again. NaCl, MgCl2, CuO. Okay, so we see that these are some chemical formula of some compound. Sodium chloride, magnesium chloride, copper oxide. Yes. So what we see here is the common are sodium, magnesium, copper. All these are metals. Yes. So when a compound consists of a metal and non-metal, okay, the name or symbol of the metal is written on the left. And the non-metals are written on the right. Okay. H2O. Now let us see here. H2O is a molecule. Is a compound. It contains two hydrogen atom and it contains one oxygen atom. Yes. So we have two hydrogen atom and one oxygen atom. Let us see. So two hydrogen. The atomic mass of hydrogen is 1 and we have one oxygen atom. So 1 into the atomic mass of oxygen is 16. So when we add them, we will get 2 plus 16 equal to 18 U, atomic mass unit. Yes. So the molecular mass of a substance is the sum of the atomic mass of all the atoms in a molecule of the substance. Okay. So like we have seen, taking the example of H2O, the water molecule, we can calculate the molecular formula of a substance by adding the atomic mass of all the atoms in a molecule. Okay. So this is the molecular mass. The molecular mass of a substance is the sum of the atomic masses of all the atoms in a molecule of the substance. Relative mass of a molecule expressed in unified mass units, it is represented by the small letter U. Okay. Now here we have sodium chloride. Yes. So formula unit mass. We see that, okay, in salt, okay, the common salt, the chemical formula is NaCl. Na plus Cl minus. Okay, the atoms are, it carries charges. Yes, the atoms that makes up the sodium chloride, it carries charges. Yes. So formula unit mass. What is formula unit mass? Formula unit mass is the sum of the atomic masses of all atoms in formula unit of a compound. The word formula unit is used for those substances whose constituent particles are ions. Okay. So the difference between molecular mass and formula unit mass is that molecular mass is used for all other molecules or all other compound. Formula unit mass is used for those substances whose constituent particles are ions. That means it carries positive charge or negative charge. Now let us see here. We have 4 hydrogen atom, 2 oxygen atom. Yes. So we see that we have two, let us see, we have 2 hydrogen molecules and we have 1 oxygen molecule. When we combine 2 hydrogen molecule with 1 oxygen molecule, we get 2 water molecules. 2H2O, right? 2H2O. So we have 2 water molecules when we combine 2 hydrogen molecules with 1 oxygen molecules. So let us see. Okay, 1 into the atomic mass of hydrogen is 1. We have 4 oxygen atoms here, so 4, 1 into 4. We have 2 oxygen molecule here. The atomic mass of oxygen is 16. So when we combine this, we get 4U, 4 atomic mass unit and 32 atomic mass unit. Now let us calculate for 2 water molecules. So we get 36 atomic mass unit. Okay, so the molecular mass of 2 water molecules will be 36 atomic mass unit. Now you will see that the atomic mass unit of the constituent particles or the constituent molecule is equal to this one. Yes. So it is more convenient to refer to the quantity of a substance in terms of number of molecules, number of its molecules or atoms rather than their masses. Okay, so instead of using their masses, it is more convenient to use the molecules. So we use 2 hydrogen molecules plus oxygen molecules to 2 water molecules instead of the atomic mass. Okay. Even in a small amount of any substances, we find a large number of atoms or molecules. Okay. Alright, students, we have another question. Please get your rough devices ready. The question is, molecular mass is sum of dash of the elements present in a molecule. So I'm giving you 15 seconds for this question, students. Your time starts now. Molecular mass is sum of dash of the elements present in a molecule. Option A is electron, option B is nuclear mass, option C is atomic mass, and option D is nucleus. So which of the following option is the correct answer? Yes, students. Alright, students, your time is up, and yes, very good. The correct answer is option C, that is atomic mass. Molecular mass is sum of atomic mass of the elements present in a molecule. Very good, students. Now let us see here. Pair of socks. Okay, we have pair of socks. We have pair of shoes. We have 1 dozen apples. We have 1 dozen marbles. We have century, meaning 100 runs. Right? So we know that pair means 2 in number, and dozen means 12 in number. Century means 100. Yes. So similarly, 1 mole is equal to 6.023 into 10 to the power 23. Okay, just like pair is equal to 2, dozen is equal to 12, 1 mole is equal to 6.023 into 10 to the power 23. Okay, this is a numerical quantity used to determine the number of atoms or molecules or ions in a substance. Okay, 1 mole of a substance is the amount of the substance which contains as many particles, that is atoms, molecules, ions, etc., or entities that are equal to the atoms present in exactly 12 grams of 12 carbon isotope. Okay, 1 mole is a huge number. It is this number. Okay, so we write it as 6.023 into 10 to the power 23. We have here Wilhelm Oswald. Okay, the word mole was introduced around 1896 by Wilhelm Oswald. Mole term is derived the term. Okay, mole term is derived from the Latin word moles. Okay, it means heap or pile. 1 mole is a huge number. We have seen this. This constant number is known as Avogadro's number. Okay, remember this name, students. If they ask you what is Avogadro's number, this is the Avogadro's number. Okay, Avogadro's number is represented by the capital letter N. Okay, so Avogadro's number is represented by N. Here N represents Avogadro's number and not the element nitrogen. Okay, so Avogadro's number is this one, 6.023 into 10 to the power 23, number of atoms. Okay, is known as the Avogadro's number, and this Avogadro's number is named in honor of the scientist Amedeo Avogadro. Okay, know this. Amedeo Avogadro from 1776 to 1856. Okay, he was an Italian scientist. He was a professor of physics at University of Turin, and he is most noted for his contributions to Avogadro's law. Alright, students, we have another question. Please get your rough devices ready. The question is, the number of molecules in 16 gram of oxygen is which of the following? I'm giving you 15 seconds for this question. Your time starts now. Yes, students, the number of molecules in 16 gram of oxygen is which of the following? Option A is 6.023 into 23, B is 6.02 into 10 to the power minus 23, C is 3.01 into 10 to the power minus 23, and D is 3.01 into 10 to the power 23. Alright, students, your time is up, and yes, here the correct answer is option A. Okay, 1 mole of oxygen is equal to 16 gram. We know that 1 mole is equal to 6.023 into 10 to the power 23. So here the correct answer is option A. Okay. Alright, students, let us see here. Here we see hydrogen elements, and here we see a group of carbon atoms, and here we see hydrogen molecules. Alright, so let us see here. So 1 mole of carbon atoms, let us see, okay, 1 mole of carbon atoms is equal to 6.023 into 10 to the power 23 carbon atoms. 1 mole of hydrogen atoms will be equal to 6.022 into 10 to the power 23 hydrogen atoms. Again, 1 mole of any atoms or molecules will be equal to 6.022 into 10 to the power 23 of that atoms or molecules. So let us see. Here we have banana and we have bangles, right? So when we say dozen, it may be banana, it may be other items, but the number will remain the same, right? So 1 dozen is equal to 12. 1 dozen of apple will be equal to 12 apples, right? But the kg, the weight may be different. The mass of this 1 dozen of apple may be different. It may be 3 kg. 1 dozen of banana will also be equal to 12 pieces of banana, but the mass of the banana may be different from the apple. It may be 2 kg. 1 dozen of egg will be equal to 12 pieces, but the mass will be different. Yes. So here we see that 1 dozen means 12 pieces, but the mass of each item can be different. Yes. So similarly, even in mole, okay, 1 mole of carbon atoms will be equal to 6.022 into 10 to the power 23 carbon atoms, okay, but the mass will be different, okay, 12 gram. We see that it is 12 gram. For 1 mole of hydrogen atoms, it will be equal to 6.022 into 10 to the power 23 hydrogen atoms, but the mass of hydrogen atom will be different, that is 1 gram, okay. So 1 mole of water molecules will be equal to 6.022 into 10 to the power 23 water molecules, but the mass will be different. Yes, it will be 18 gram. And 1 mole of sodium ion will also be equal to 6.022 into 10 to the power 23 sodium ion, but the mass will be different. Okay, so here we can see that 1 mole of carbon atoms is equal to 6.022 or 23 into 10 to the power 23. Okay, so from here we can see that 1 mole of atoms or molecules will be equal to 6.023 into 10 to the power 23 atoms of given atoms or molecules, right? The number is the same, but the mass is different for each cases. Like similarly, like we have seen with banana, apples and egg, 1 dozen means 12 apples, 12 bananas, 12 eggs, but the mass is different, right? So similarly, even in elements and compounds or molecules, okay, we see that the 1 mole will be equal to the same number of that atoms or molecules, but the mass will be different. So what is molar mass? Okay, the mass of 1 mole of a substance which is expressed in grams is called its molar mass. Okay, numerically molar mass will be equal to molecular mass, but their units are different. Okay, the molar mass, the units of molar mass will be in gram, and the units of molecular mass will be in unified mass units known as represented as U. Okay, so molar mass is equal to molecular mass, but their units are different. Molar mass is expressed in gram and molecular mass is expressed in unified mass unit. Example, molecular mass of water is 18 U and molar mass of water is 18 gram. Okay, mass of 1 mole is equal to gram atomic mass by gram molecular mass. Okay, unit of atomic or molecular mass is U. Okay, unified mass unit. So here we see that it differs only in the unit, that is from unified mass unit to gram. Molar mass of atoms is also known as gram atomic mass. Okay, gram atomic mass. So let us see here. We have 2 hydrogen atoms and 1 oxygen atom. When they combine, they form water molecule. Yes. So let us see. We have the atomic mass of hydrogen is 1. We have 2 oxygen atoms, so 1 into 2. The atomic mass of oxygen is 16. We have only 1 oxygen atom here, so 1 into 16. So we have 16U plus 2U, we will get 18U, right? So this is the molecular mass of water. Okay, this is the molecular mass of water. It is expressed in terms of unified mass unit. Now 18U is also equal to 1 molecule of water. Okay, and we have seen that molar mass is expressed in terms of gram. So 18 gram is the molar mass of water, and 18 gram of water will be equal to 1 mole of water molecules. Remember the difference, okay? Molecular mass is expressed in terms of unified mass unit. 18U will be equal to 1 molecule of water, and 18 gram molar mass is expressed in terms of gram. So 18 gram will be equal to 1 mole of water molecules. That is 6.023 into 10 to the power 23 water molecules. Alright students, we have numerical problems. Let us solve one too. Okay, calculate the number of moles present in 52 gram of helium. So let us see. Okay, solution. Given mass of the helium is 52 gram. Yes. Atomic mass of helium is 4U. Okay, molar mass of helium M is equal to 4 gram. So number of moles is given by given mass by molar mass. Yes. So let us substitute the value. The given mass is here is 52 gram. Yes, and the molar mass is 4 gram. So when we divide this, we will get number of moles is equal to 13. So the number of moles present in 52 gram of helium is 13. Okay. Another example, let us see. There are 12.044 into 10 to the power 23 numbers of helium atoms. Find the number of moles from number of particles. So let us see. Number of particles is given to us. Let us find the number of moles. So given number of particles is equal to N. Okay, it's equal to 12.044 into 10 to the power 23. Number of moles, okay, is equal to N. It will be equal to, we have to find this one. Okay, we have to find the number of moles. Avogadro's number of particles is given by N naught is equal to 1 mole, will be equal to 6.022 into 10 to the power 23. Okay, so we have here this value for Avogadro's number. Number of moles will be equal to given number of particles by Avogadro's number. So when we divide the given number of particles and Avogadro's number, we will get N is equal to capital letter N, that is the given number of particles divided by the Avogadro's number, so N naught. So when we substitute the value, we will get, let us see. Okay, when we substitute the value and do the calculation, do the division, we will get number of moles is equal to 2. Okay, so the number of moles, okay, in 12.044 into 10 to the power 23 number of particles is 2 moles. Okay, so there are 2 moles in this question. Okay, from this question the number of moles will be equal to 2. Alright. Alright students, expressed in mole. Let us solve this one. 12 gram of oxygen gas. Okay, 12 gram of oxygen gas. So atomic mass of oxygen we know is 16U. So the molar mass of oxygen will be 16 gram. Yes. So number of moles is equal to, let us see, given mass by molar mass. Yes. So here the given mass is 12 gram and the molar mass here is 16 gram. So when we calculate this, we will get number of moles is equal to 0.75. Okay. Alright, activity students. Convert into moles. This you can take it as your homework. Okay. Convert into moles. Convert 20 gram of water into moles. Convert 22 gram of carbon dioxide into moles. Okay. Alright students, we have another question. Please get your rough devices ready. The question is, the mass of one carbon atom is, okay, I'm giving you 30 seconds for this question. Students, your time starts now. The mass of one carbon atom is option A 6.023 into 10 to the power 23 gram. Option B is 1.99 into 10 to the power minus 23 gram. Option C is 2.00 gram. Option D is 12 gram. Yes, students. Alright, students, your time is up, and yes, very good. The correct answer is option D, that is 12 gram. Okay, the mass of one carbon atom is 12 gram, right? Mass of one carbon atom is, we have seen that the atomic mass of carbon atom is 12 U, unified mass unit. So the mass of one carbon atom will be equal to 12 gram. Okay, very good, students. Alright, students, so in today's class we have discussed about the valency, right? The combining power or the combining capacity of the element is known as its valency. We have also seen how to write chemical formula for molecules and compound. Yes, we have seen the different rules, the different steps that we need to follow to write the chemical formula of the compound. We have seen what is molecular mass. Yes, students, the molecular mass of a substance is the sum of all the atomic mass of all the atoms in a molecule. Yes, we have seen formula unit mass. It is the sum of the atomic mass of all the atom in a formula unit mass. And formula unit mass is used if the constituent particles of the substance is ion, meaning it carries positive charge or negative charge. Then we have seen 1 mole is equal to 6.022 into 10 to the power 23. This number is also known as Avogadro's number. We have also seen molar mass. Yes, the mass of 1 mole of a substance which is expressed in grams is known as molar mass. Okay, so these are some of the things that we have discussed today. I hope you are clear with what we have discussed. Yes, students. Alright, students, so this leads us last question for today. Please get your rough devices ready and respond to this question. Okay, how do you feel about today's class? I'm giving you 25 seconds. Your time starts now. How do you feel about today's class? Option A is happy. Option B is quite good. Option C is satisfactory. Option D is confused. Yes, students, how do you feel about today's class? Alright, students, your time is up. Thank you so much for your response and thank you for joining today's class. I will see you again in our next class. Till then, take care everyone and have a nice day.